Welcome back, my friends. So in the previous videos, we introduced or focused on the subatomic particles for an element, protons, neutrons, and electrons, talked about their properties and importance, where they're located in the atom, how to write in a shorthand method how many protons, neutrons, and electrons an element has. Let's focus for a moment on the symbols associated with an element. So on the periodic table, each element has a 1 or 2 letter abbreviation as a symbol. It also has a corresponding name. Now, looking at the periodic table, you'll see that the symbols for elements, some are a little more obvious than others, like oxygen for O, calcium Ca. There are some that maybe aren't as obvious. Things like iron and copper and gold. Their corresponding symbols and names actually come from an earlier name, mainly Greek or German. So elements have symbols, 1 or 2 letters. They are on the periodic table. Elements also have names associated with them. And so it might be, hopefully at this point, you have your periodic table in front of you, the one that I have given you in class. And you see that, oh, okay, yeah, I see those symbols of the elements, and I see the atomic number and the atomic mass. We talked about those, but I don't see any names of elements. Well, you are going to have to memorize names of certain elements. This is a college chemistry class. You're going to need to be able to have those names of the elements sort of on the tip of your tongue to be able to do the problems associated in this class. So that begs the question, which ones do you need to memorize? And so this is a good rule of thumb, which is that you need to know the associated names and symbols for elements with atomic numbers 1 through 36. So that's from hydrogen through krypton. Plus any names or symbols that are associated with the dry lab on nomenclature. It's actually under chapter 2. I have a worksheet of about 100 different problems for you to practice doing nomenclature on, and we're going to talk about nomenclature in subsequent videos. The take-home message is that you do need to memorize the names associated with symbols on the periodic table 1 through 36, plus any symbols that are used on the chapter 2 nomenclature worksheet that is on Canvas. So I would highly recommend getting a stack of note cards, maybe putting the symbol on one side and the name of the element on the other, and go through those 5 to 10 minutes a day just to kind of work into your brain the names associated with those particular elements. So now this will be our last slide for this little vignette, but let's introduce the concept of isotopes. And in the next video, we're going to do some problems associated with them. So if you look at the periodic table, you see that all of the elements, they all have their own unique number of protons. Like carbon has 6 protons. It has an atomic mass of 6. But it is possible to have different flavors, as I like to say, of a particular element due to differences in atomic mass. So on this table, what is listed, I have 4 different elements. They're all carbon. They all have 6 numbers of protons. But looking at this shorthand symbol, you see that this flavor of carbon, it has an atomic mass of 11. This second carbon has an atomic mass of 12. What's up with that? Well, it turns out that certain elements exist in forms that we call isotopes. Isotopes are elements that they have the same number of protons as the element in that sample, but where they differ is in their atomic mass, so specifically in their number of neutrons. Okay. Isotopes are really, really important in lots of applications, in medical applications and research applications. You talk more about that in Chem 2 and if you go on and take a biochem class. Do you need to memorize if certain elements have isotopes? No, not at all. But you do need to be able to do some word problems associated with isotopes, meaning if I give you some information about an element, be able to tell me for that particular isotope how many protons, neutrons, and electrons it has. And then we'll also talk about how to calculate the mass of that isotope. Okay? So this is where we're going to stop for this video. In the next videos, we're going to talk about how to use the definitions of atomic mass and atomic number along with isotopes to determine numbers of protons, neutrons, and electrons for a species. And then we'll talk about how to calculate the average atomic mass for a particular isotope.